students, in this lecture we are going to study one or two examples on recursion. So in the previous lecture we have seen that recursion is a special case of nesting of function. What is nesting of function? Function which calls another function. So in recursion, function calls itself. Let's see one example where main is the function. Inside the main we have printf. This is an example of recursion. So this statement will be printed, okay, and then we are calling the main function. So you can say that this particular main function is calling itself. Inside the main function we are calling the main function again. So it is called recursion. So these type of functions are called recursive functions. So as you can see, this particular program will execute indefinitely because we are calling this particular function multiple times. We have not put any stopping condition, right? We have not told the compiler at what time or at what level it has to stop executing the printf statement. So this particular function will go on calling itself. That's why this is an example of recursion. This output will be printed multiple times, and at some point of time we have to stop the execution, otherwise execution will go on. It will never stop. So at some point of time we have to interrupt the execution. So if you interrupt the execution, it would give the result like this and it will stop the execution. So this type of stopping the execution is called forceful, or execution is terminated abruptly, or forceful termination. Okay. So let's see one example on recursion. So another example of recursion is the evaluation of factorials of a given number. You all know what is how to find a factorial of a number, right? What is a factorial of a number and how to find it? The factorial of a number n is expressed as a series of repetitive multiplications, right? So if I want to find the factorial of n, then I have to go on multiplying n with its previous numbers, n minus 1 into n minus 2, so on up to where? 1. Till I reach 1, I have to go on multiplying the numbers, right? So this is the logic for factorial. Now let's say how we can implement this factorial using recursive functions. I will start with main. So I have defined one variable called a. Here a variable is nothing but a variable or the number which we want to calculate the factorial for. You can see that this is our function declaration. It is not calling function, it is the function declaration part. Int factorial, and int means the factorial function is returning integer data type and also it takes integer input. This is local declaration, right? Because we have not declared this function outside the main, so it becomes local declaration. And then we ask our user to enter some number. Enter the number. That will be done by using printf statement. We are going to display enter the number by using printf statement, and by scanf we are going to take the input for variable a. And then after giving the input, we have to find the factorial for that number, right? So I am combining two statements here. So I am calling the factorial function as well as I am printing the result in the same statement. This is possible, right? Calling function can be combined in printf statement. We have seen in our previous examples also. Or you can split these two into two different statements. That is, you can declare one more variable and you have to say b is equal to factorial of a. Then instead of factorial of a here, you can just put b, right? You can split these two or this one statement into two different statements. Okay. However, I am taking these two things in the same line. Printf the factorial of %d. Here %d indicates our a. Factorial of a is %d. This is our result. So the first %d indicates variable a, that is number entered by the user, and the second %d indicates it is the result returned from the factorial. Correct? Okay. So since we are calling factorial a here, factorial of a, we are passing a inside factorial, means we are passing the input which is given by the user inside the factorial function. So once the control comes here, it will jump to this particular statement. It will see that the function data type is int, means our factorial function is going to return integer data type. Okay, then factorial int x. What is stored in x? Whatever the value we have passed in a will be passed on to x. Then we have declared one more variable called int f. This is for holding the result returned by factorial, or this is for result of factorial. This is nothing but the variable which holds the result of factorial of a number. Okay. If x equals to 1, if the input given by the user is 1, then what is 1 factorial? 1 factorial is nothing but 1 itself, right? Yes or no? Yes. That's why if x equals to 1, then we are going to return 1, because 1 factorial is 1, that's why we would return 1 to the calling function. Else, if the number entered by the user is not 1, then we have to find the factorial of that number. Say if the number entered by the user is 2. Okay, the compiler will check x equals to 1, that is 2 equals to 1, no, that's why else statement will be executed. F is equal to, what is x? X is 2 here, and then see, this is again calls the factorial function. That's why it is called recursive function, because see, this factorial function is calling itself again. That's why it is called recursive function. Now we have to find the factorial of x minus 1. Here what is x? 2. 2 minus 1 is 1. Okay. So since it calls our factorial function again, the control jumps again here. It says factorial of, now x is 1, x minus 1, that is 1. So 1 will be passed. Again it checks the condition, if x equals to 1, yes, this time it is yes, that's why it returns 1. It returns 1. 1 to where? Here it returns 1 to the calling function. Who is the calling function? This one? No. this particular function is calling this particular statement, right? Yes or no? That's why 1 will be returned to this particular function, not here. Okay, that's why 1 will be returned here, and 2 into 1, that is 2, return f. F will be having 2 now. So after calculating the result, it is going to return f, that is 2. Return 2. Return to where? To its calling function. Who is the calling function for this return? This factorial. That's why 2 will be returned here. Yeah, let's take the input as 5 and let's check how it is going to work. So now the user enters 5 here. Okay. The factorial of %d. What is %d factorial? That is 5 factorial. 5 factorial is %d. That is factorial of a. So the control comes here and it encounters calling function. So it would jump here. Int factorial of int x. What is x now? It is 5, right? Yeah. Okay. 5 will be passed. The compiler checks the first condition. If x equals to 1, is x 1? No, it is 5. So no, this part will not be executed. It comes to the else part, and f is equal to x. What is x? 5 into, again it has to call factorial 5 minus 1, that is factorial of 4. Factorial of 4 will be called. So again 4 will be passed now. Factorial of 4. Again the compiler checks if x equals to 1. No, because x is 4 now. So x is not 1. That's why what happens? It comes to the else part. Now f is equal to x into factorial of, now what is x? X is 4. Into factorial of 4 minus 1, that is 3. Again factorial of 3 is called. Again it checks x equals to 1. No, that's why again it comes to else part, and it again computes x into factorial of x minus 1. Again it computes 3 into 3 factorial of 3 minus 1, that is 2. So this continues until x reaches 2. Once x becomes, x reaches 1. Once x becomes 1, the compiler checks the condition. If x equals to 1, yes, that's why it returns 1. Returns 1 where? To its calling function. Who is the calling function for this return 1? This one. That's why after 2, 1 will be returned here. 1 will not be returned here, because this is not the calling function for this return 1. This is the calling function. Now f stores 5 into 4 into 3 into 2 into 1, that is 120. Now f is having the result 120. Finally this particular factorial function returns 120. This 120 will be returned to whom? Who is the calling function for this factorial or this return? This one, right? That's why 120 will be returned here. So it would say the factorial of 5 factorial is mod or %d, that is 120. So this is very important example of recursion. Okay. So in the next video we are going to see one more example of recursive function, that is Fibonacci series.